Velocities. In general, suppose an object moves along a straight line according to an equation of motion, s is equal to f of t, where s is the displacement, which is the directed distance. So here we can look in the graph from 0 to s of the object from the origin at time t. The function f that describes the motion is called the position function of the object. In the time interval from t is equal to a to t is equal to a plus h, the change in position is f of a plus h minus f of a. So here we can see that the position at time t is equal to a as it's moving along from the origin. So here's where it's the position at time a, and as it moves to this part, it's going to be the position at time t is equal to a plus h, where 0 to s is the distance or the directed distance. So from 0 to point A is f of a, and from 0 to this point, a plus h is f of a plus h. So the average velocity over this interval or this time interval is the following. Average velocity is equal to the displacement divided by time, which is equal to f of a plus h minus f of a over h, which is the same as the slope of the secant line PQ in the figure below. So very similar to what we've done in our previous examples. So this actually equals the average velocity. So now suppose we compute the average velocities over shorter and shorter time intervals, a and a plus h. In other words, we're going to let h approach 0. So we define the velocity or instantaneous velocity v of a at time t is equal to a to be the limit of these average velocities. So the average velocity v of a is equal to the limit as h approaches 0 of f of a plus h minus f of a divided by h. And this means that the velocity at time t is equal to a is equal to the slope of the tangent line at